When you wash your clothes and hang them outside for drying, you observe that after some time they dry up. Say the temperature outside is 35 degrees Celsius or 45 degrees Celsius. Similarly, if you drop water on table or on the floor, you observe that after some time the water vanishes. Say the room temperature is around 28 degrees Celsius. So where does this water go? What happens to this water? So this water on the table or on the floor and the water from your clothes, it evaporates. What is evaporation? It's the process of the change of the liquid state to the gaseous or the vapor state. So whenever the liquid changes into the gaseous state below its boiling point, that is known as evaporation. You know that boiling point of water is 100 degrees Celsius. But when you hang your clothes outside, the outside temperature is around 35 to 40 degrees Celsius. And when you drop water on floor, the room temperature is around, say, 28 to 30 degrees Celsius. So it is much, much below the boiling point of water. That is why the change of liquid state to the gaseous state below the boiling point, this phenomena is known as evaporation. How does the process of evaporation take place? Let's see. So this is the kinetic model of liquid state. These are the particles of liquid. So if you'll observe, you see that the particles which are on the surface, they have lesser intermolecular forces of attraction as compared to the particles in the bulk. They have stronger intermolecular forces of attraction from the particles on all sides. These particles on surface, they do not have liquid particles on top of them. So these particles, when they extract heat, even a little heat from the surroundings increases their kinetic energy to such an extent that they overcome these forces of attraction and they escape as gas. So evaporation is a surface phenomena because we talk of the molecules or the particles which are present on the surface. So let's see again how evaporation takes place. So as temperature increases, that is, in case of evaporation, heat is extracted from the surroundings. This increases the temperature. The kinetic energy of the surface particles increases tremendously, because of which the speed of the surface particles increases. Due to this, the interparticle space between the surface particles increases. And as a result of this, the interparticle force of attraction of the surface particles decreases. Therefore, they escape as gases. So the liquid on the surface, since evaporation is a surface phenomena, so the liquid particles on the surface, they change into the gaseous state. Because even a little heat from the surroundings increases the kinetic energy of these surface particles tremendously. And so they escape as gas. Let's see now what are the different factors on which evaporation depends. Well, when you wash your clothes, how do you keep them for drying? Do you fold them and stack them one on top of another? Or do you open them wide and hang them on the rope? Well, obviously, you open them wide and hang them on the rope. Why do you do that? This is because evaporation increases with the increase of surface area. We know evaporation is a surface phenomena. So greater the surface available, greater number of particles escape as gas. So in this case, you know that the surface of each cloth, the surface available for evaporation to take place is much less as compared to when you keep your clothes out for drying in the open form. So in this case, you see that the surface available for each cloth is much, much more as compared to when you fold them together and stack them one on top of another. That is why in this case, the surface area increases, more particles evaporate, and that is why the rate of evaporation increases. Alright, now do your clothes dry faster on a cloudy day or on a sunny day? You must have observed that your clothes dry faster on a sunny day. Why is that so? Because on a sunny day, the temperature outside is much higher as compared to that on a cloudy day. As the temperature increases, greater number of particles absorb the heat from the surroundings, and so greater number of particles escape as gases. That is why on a sunny day, the clothes dry faster as compared to that on a cloudy day, because the increase in temperature increases the rate of evaporation. Humidity. Humidity is defined as the amount of water vapor that is present in air. How do you know that there is water vapor in the air? So if you take a very cold bottle, take it out from a freezer and you keep it outside, you see that small liquid droplets are formed on the surface of the bottle. Why does that happen? This is because there is water vapor in the air. When that water vapor comes and strikes this colder surface, condensation takes place. How does condensation take place? Let's see. So when the water vapor in the air, it strikes the cold bottle, the temperature of the particles decreases. Since that bottle you have taken out of the freezer, so the temperature of the bottle is less, so the temperature of the water vapors coming in contact with the bottle decreases. So the kinetic energy of these particles decreases. As the kinetic energy decreases, the speed of the particles decreases. This leads to interparticle space between the particles decreasing. As this happens, the interparticle force of attraction between the particles increases. And so the water vapor which is present in the air in the gaseous form changes into the liquid. And this is why you observe the small liquid droplets that form on the surface of the bottle. This is because there is water in the air. And this amount of water which is present in the air is measured in terms of its humidity. So now as humidity decreases, what happens when humidity decreases? The amount of water vapor in the air decreases. Since the amount of water vapor is a measure of humidity, so as humidity decreases, the amount of water vapor that is present in the air, that decreases. If that takes place, the amount of water vapor that can now be accommodated in the air increases. Since now, the amount of water vapor which is already in the air, it's less because it's less humid. Therefore, now more and more amount of water vapor can be accommodated in the air. And this is why evaporation increases. And so we observe that evaporation increases with the decrease in humidity. Lesser the amount of water vapor that is present in the air, more water vapor can be accommodated, and therefore evaporation increases with the decrease in humidity. So when you are hanging your clothes out for drying, what do you observe? Do your clothes dry faster on a day which is windy or on a day which is not windy? You know that the clothes dry faster on a windy day. Why is that so? Consider the day when it is not windy outside. So as the clothes dry, there is water vapor in the air, because as they dry, the water from the clothes evaporate. So now the surrounding air contains greater content of water vapor. So now the accommodation for new water vapor decreases, since the surrounding air already has a lot of water vapor. So the rate of evaporation decreases. What wind does is, it carries away the water vapor from the surroundings of the cloth. So now as the wind speed increases, that is, the day is windy, it carries away greater amount of water vapor with it. So now the surrounding air has space, or it has capacity to hold more water vapor. So now the rate of evaporation increases, there is more space for this water vapor to be accommodated in the air, and that is why on a windy day the clothes dry faster. This is because the rate of evaporation increases on a windy day. Let's recall what happens on a windy day. As the wind speed increases, it carries away greater amount of water vapor. The water vapor which was present in the air surrounding the cloths. So now this carries away greater amount of water vapor with it. So the amount of water vapor that can now be accommodated in the surrounding air, that increases. Since that increases, the rate of evaporation increases. So on a windy day, the clothes dry faster. This is because the rate of evaporation increases on the windy day. Evaporation increases with the increase in wind speed. Let's now see how evaporation causes cooling. You must have observed that at times when you are sweating and you sit in front of the fan, you experience a cooling effect. So sweating causes cooling. How is it taking place? Let's see. We know when sweat evaporates, that is when you sit in front of the fan, the sweat evaporates. As it evaporates, the higher kinetic energy molecules, they escape by extracting heat. We know evaporation is a surface phenomena. The molecules on the surface, they have greater kinetic energy. So they extract heat from the surroundings. So this sweat, it extracts heat from the surrounding as well as from your body. When it extracts heat from the body, the remaining molecules that are left, they have lower kinetic energy. Since it extracts the heat from the body, so the molecules that are left behind, they have lower kinetic energy. And since they have lower kinetic energy, that means they have lower temperature. So as the higher kinetic energy molecules escape by extracting heat, they extract heat from the surroundings and from your body. So when they extract heat from the body, the remaining surface that is left behind is cooler. That is why evaporation or sweating, it causes cooling. You must have observed that during summers, when you keep water in earthen pots, it remains cool or it is cooler. Why is that so? This is because this earthen pot, it has small pores in it. So when you keep water in this earthen pot, the water which is kept inside, it evaporates. It evaporates through the surface and through the pores which are present on this earthen pot. As the water evaporates, it extracts heat. It extracts heat from the surroundings as well as from the water which is present in the bulk. So since the water on the surface evaporates by extracting heat from the remaining water left behind is cooler. So let's recall what happens. Why is the water in the earthen pot cooler? This is because as evaporation takes place or as the process of evaporation increases, the higher kinetic energy molecules, we know that the higher kinetic energy molecules are present on the surface. Since evaporation is a surface phenomena, so when these kinetic energy molecules, the higher kinetic energy molecules on the surface, they escape, they extract heat. This heat is extracted from the surroundings and from the remaining water. That is why the remaining molecules, that is the remaining water molecules, now have lower kinetic energy. This means they have lower temperature and that is why they are cooler. So when the higher energy molecules on the surface, they escape, they extract heat from the surroundings and from the remaining water. So the water which is left behind is cooler. That is why water kept in an earthen pot remains cooler during summers.